livestream. Ik ga even het beeld gaan staan. Hoi. Zijn er nog twee waarschijnlijk niet gekomen? Zijn er nog twee andere waar?
10 uur later vertellen, 20 uur zelfs te lang.
Ja, en even gecontroleerd. We zijn al live.
Yes.
Maar eerst kijken hoe het geluid hoe dat werkt. Ja, ik hoor mijn eigen al als ik hier spreek. Heb je een verloop nodig naar VGA HDMI? Ah ja, oké. Ja. Misschien dat zijn een puntje ergens liggen.
Altijd zeggen.
Ja, ja, ja. Heb jij zo'n sleutel?
Yes.
Ah. Dus je kan dan de camera gewoon in het teamlokaal zetten als je klaar bent?
Ja.
Ja. Dus deze mag blijven staan?
Ja.
Dus je moet hem gewoon, ik zal misschien eerst nog uitleg geven. Er gaan er toch nog twee toekomen, dus we kunnen starten gewoon later. Dus deze moet je losdraaien. En dan kun je de camera, hier los dan kun je de camera eraf nemen.
Ja, en dan voorzichtig.
Ja, hier gewoon een klapje dicht doen.
Yes.
En dan is hier gewoon uitschakelen.
Ja.
En dan is eigenlijk gewoon alles in de doos steken.
Ja.
In deze uitdoen is hier achteraan ook netwerkkabel, mag je gewoon laten liggen.
En dat bakje blijft op de
Dat
camera
mag er allemaal in
staan,
zitten. Ja, het enige is dit stuk. Moet je hier zo'n beetje insteken en dan is die hier.
Dus ik ondersteboven dat
Voilà,
die...
ja, dan kan die er net in. Dat is een fotootje.
Oké, dus als ik hem gewoon stopzet hier dan... Hier moet er niet op record of zo, nee, dat is...
Nee, hij is nu al bezig.
automatisch,
Dus
ja.
eigenlijk als je klaar bent, het enige dat je doet is, je doet hem hier gewoon uit en dan gaat de livestream stoppen.
Ja, oké.
Ja. Wij nemen ook altijd goed dat je schermopnamesoftware hebt.
Ja, dat zit standaard op mij.
Ja.
Ja.
Wij doen dat ook altijd.
Ja.
Als er iets fout gaat, dan kunnen we de volgende dag dat altijd online zetten.
Yes. En is het scherm enkel in duplicaat of kunnen we zo uitbreiding doen?
Je kan kiezen
Precies,
normaal.
oké,
Normaal
ja.
zou je moeten kunnen kiezen. Ja.
Ja.
Anders moeten we ondertussen nog een keer proberen aan te sluiten. Ik heb ook van wie de aftekenlijst.
Ja.
Die ligt hier. En dan zit al getekend. Ja. Dus dan als er nog studenten toekomen ook laten tekenen en dan mag je die gewoon voor de volgende contactmomenten bijhouden.
Perfect.
Sowieso onmogelijk vertragen nog. En ook, hier moet je gewoon, de micro hier
Ja, dat kan ik
en daar ook. Ja.
En daar ook?
Ja, daar ook. Dus er zit een ontvangblok. Dat is nu momenteel beeld en dat dat goed is. Yes. Dit is de eerste keer dat je via de livestream of heb je al vroeger al gedaan?
Nee.
Ah ja.
Toen was dat gewoon een schermopnames die achteraf gebeurd waren.
Ja. Yes. Misschien nog achteraan het licht aansteken straks. Uit Gent. Stop.
spoor. Hoe dat daar zo trouwens? Het is altijd op de trein nadenken. Dat is meestal een nadenken.
Oké,
Hier ook bij
ja, dat is zo. Ja. Voilà. Succes.
Yes. Yes, let's start. So welcome to the first lesson of database technologies. Let's start with a short overview of how this course is going to look. So you should be able to, by the end of the 3 sessions, to solve exercises both on normalization and database creation, create your own database model, and recognize several database types, and of course use some online databases. As course material, there are some slides available on Lego, as well as a syllabus. And the examination will be a theoretical part, which is closed book, and a practical part, consisting of exercises, as we've seen throughout the course. And this part is open book. Basically, all you need is a working internet connection, and of course your Unix system by preference. For people working on Windows, it should not be a problem, but of course it's more convenient working on a Unix system. So let's start with the general introduction, and then ease our way into relational databases. So a typical law in informatics that's used quite often is Moore's law, and it actually says that the number of transistors that can be placed inexpensively in any system or in an integrated circuit doubles approximately every 2 years. Well, at least that was the case. By now, this is going way more exponential. And this law is also expandable for other formats in informatics, and also for our databases. So basically saying that the amount of data that we want to store more than doubles every 2 years. So actually, as a database, well, databases are just mechanisms used to store information, and this information can be any kind of information. It can be numbers, text, date, and most of the time this data is structured in or stored in a structured way to allow the user to have an efficient interaction with the data. And this is formulated in the ways of CRUD. And what does CRUD stand for? Well, we'll come back to that later, but for now you just have to remember that CRUD stands for create, read, update, and delete. So you can create new data read your data from your database, update your data in your database, and delete data from your database. And databases are used everywhere. I'm sure that all of you have been working with some kind of database at some point. So the main build-up from a database is you have your computer with your hardware. On your computer you have your software which stores your data. This together interacts with one or more users, and this is your entire database system. So to come back on this, you have your hardware, which is just your personal laptop or a server cluster. Your data, which is stored in a structured manner with little or none redundancy. It can be sharded, meaning that you have single user instances versus multi-user instances, so a database for personal use or a database you share with other users. And then, of course, to interact with your database, you will need some kind of software, which is your database management system. And this is used to store, retrieve, and manipulate your data, as we mentioned before, with our CRUD operations. And then, one of the most important parts, of course, of your database are the users. And different users have different roles, so meaning that if you're an administrator, you get more rights on your database than an end user, and each user has its own authentication and authorization system. And if you look at the database more in detail, we can see that it consists out of 3 levels. We have our view level, our logical level, and our physical level. And if we start from the bottom and move our way up, our physical level is actually our hardware. Then we have our logical level is how the creator of the database thought of the system, of the way that the database has to look like. And then you have the view level, meaning how you present your database to your end user. Some characteristics of a good database system are, of course, that you have a sufficient amount of storage. So before creating your database, you have to think ahead that you do have a sufficient amount of storage, because if this is not the case, then your database will become slower. And of course, we want our results as fast as possible. Our database should be easy accessible, meaning that most of the time the database is stored on a centralized system, server of some sorts, and not your personal computer, as we will do in this course. Because if you store it on your personal computer, it means that your computer has to always be on for other users to be able to connect to the database. It has to be secure against non-users, so you can set per user rights. It has to be easily maintainable. Again, with our CRUD operations, we can adjust our data. And by preference, we want a controlled input. So all data in our database should be in a similar format. Coming back to the sufficient amount of storage, it leads to our speed. So a database is, or has to be, as quick as possible. And we can achieve this by allowing some sort of redundancy, but not too much, because if we store the same information twice or more, of course our database will become too big, meaning that we will need more storage, and if we don't have enough storage, it will become slow. If we allow a little amount of redundancy, this can speed up some queries, but we'll come back to that later on in the second contact moment. And it has to have a clear structure, so maintenance will become much more easy. Our database management system is actually, as said before, a computer software application, and it allows the user to interact with other applications and the database itself. And it allows the user to perform certain actions on our database. It also shields users from the hardware and the storage details, so meaning that for an end user, so basically us, we don't have to know how our hardware is composed. and is the most important software component, though not the only one, of course, to work with our databases. And it's used, again, for our CRUD operations and also some management operations. If you look at the most, or one of the most known database types, it's a relational database, and all of you will at some point have worked with Microsoft Excel. Well, the most simple structure for a relational database is actually a two-dimensional table, so an Excel worksheet is a kind of relational database. It consists of rows and columns, or in some other database types, these are called fields and records. And what do these relational databases contain? Well, relational databases are actually just built up out of model objects, we call them entities, and the relationships between those entities. For example, the store sells a certain product to certain customers, and then the entities are the customers and the products, and the relationships are, of course, who buys what, or which product is sold to which customer. Each of these entities can have one or more, or as many as you want, attributes. And these attributes tell us something more about the entities itself. And of course, for our relational databases, we will use a relational database management system. And these enforce our data integrity and our referential integrity. Meaning that our data has to be put in the database in a correct way. So each column has to have the correct type, and the relationship between our different columns or relations has to be strict. There are some examples of these relational database management system. We have a whole lot of commercial products, but there are also open source options. And in this course we will work with one of the open source options. Why? Well, because it's free, and of course because MySQL is one of the most widely used relational database management systems. You can download the MySQL if you want from their website. And if you would like to install it, you can just follow the installation instructions based on your operating system. The operation instructions for Linux are quite straightforward. You can just follow the tutorial, but it actually comes down to just installing the yum repository. Just let me show you the commands. So, anyone already tried to install it? No? So basically it's just copy this. So if you open your Linux terminal, and you would just enter these commands, so you can copy this URL from the website. This is readable. And you just do a sudo dnf install, then you choose your community release package. So I'll place these commands on Lego afterwards as well if you still need it. And then you can just do a sudo yum install from our MySQL community server. And this should not take more than a couple of minutes. If it takes longer, something is going wrong. This is just saying, so if you remember from your Linux lessons, it's just installing a package from this URL saying that we want the MySQL community server for Fedora 28 this is. If you have another version, you should check the website for MySQL, but I think most of you are on 28 or 29. And this is just saying we want the 8.0 version of MySQL, so the latest version. And if you install this, you should be able to start your MySQL server by just entering one of these three commands depending on your operating system. Think in Fedora, service MySQL base start should work. Depending on how you install it, you should use sudo. And you can also ask for the status by just replacing the start keyword with status. So coming down to these commands. Okay. And if you install it and started it, or ask for the status, if it's inactive, it means that your server is not running. If it's active, everything is okay. But if you try to start it and it says that you don't have access, you of course need your root password. So once your server is running, as I said before, you can check the status. So if it's running, you will get something like this. It's running, or a text message with word active in it. If it's not running, it will be inactive. And then we've set up our own MySQL server. Well, what can we do with our MySQL server? We can interact with it through the MySQL monitor. And the MySQL monitor is actually a MySQL terminal, so to speak, where you can enter SQL statements into, and it gives you a reply from your database. So it's a command line interface to interact with your database. How can you start this MySQL monitor? Well, simply by just entering the MySQL keyword, if you installed your server, of course, and it's running. And then your MySQL server will start. As with other Linux programs, it has a man page, and you can ask for that. If you have any questions, please feel free to interrupt me.
If you download the package, is it the YAML repository you have to choose for Fedora?
Yes, if you have Fedora, it's Yum, because the Yum repository is for Red Hat, I think, stated on the website, but Fedora is actually a Red Hat spin-off. Okay, and then if you started your MySQL server, you can just enter MySQL in your terminal, and then you will get something like this, saying that you don't have access as your local user, and you need a password, or you need a different. Let's check the manual for our MySQL command. So if you enter the MySQL keyword, you can give your username your password, your host name, and optionally your port on which your server is running. As we didn't change our port during the installation, it will just be the default value, so you don't have to include this. Our host name will be a local host, because we are running it on our own computer. So we don't have to change this as well. Only thing we have to give to our MySQL command is the -u and a small p. So with our username and our password. But again, what is our username? Well, we didn't select any username. So if you just install it, the only user present is the root user. So going back to our terminal, if we would do MySQL -u and then root, this will not work again, of course, because the root is protected with a password. So if you want to give your password to the command, you just have to enter the -p option. If you press enter, then it will ask for your password for your root user. If you type something, don't worry, you won't see anything, but it registers your password. Of course, you've just installed it. You don't know what the root password is. MySQL has hidden it very well. And in order to find it, you need to grab the logs for a temporary password that has been set for your root user. And on the Linux system, you can find temporary password in the log file. So if you do a grep on it, you will find in your log file the one row where it says temporary password. Just copy paste this to a text editor. You will only need it once because you will change the root password in a minute. And if you've done so, you can go back to your terminal and again enter the same command, so MySQL -u root -p for the password. Press enter, just copy paste the password from your text editor, and if you do so, you will gain access to your MySQL monitor, and it will look something like this. So it will say welcome to the MySQL monitor. And your cursor will change from your normal terminal to this one. So MySQL. And now we're inside our command line interface or our MySQL. And since we're connected to our database, we can execute these commands. So select current user will show us just as which user we are connected, and show databases will show the available databases for your use. So if you will do select current user, it will show you that I'm the root user on my local host, so root at localhost. If I do show databases, it will show me some databases that my user has access to. So in this case, I have 5 databases that I have access to. Again, our root password is not that convenient because it's a random string generated in our log file. So if you want to change it, we just have to exit our MySQL shell. And if our installation went correct, MySQL provided a program, MySQL secure installation, If you just enter this command, you just have, for once, have to copy your temporary password for your root. And then it will ask you a bunch of questions where you want to, where you can change your root password. So validate password plugin. You can choose for yourself whether you want to do it or not. For now, I will not do it. Here it asks you to change the password for root. If you want to change it to your own password, just press yes. It will prompt you for a new password. Choose something you can remember and maybe write it down somewhere. Then we want to remove the anonymous users, so here we'll answer yes. We also want to disallow root login, meaning that we can only log in as root if we're on the physical system where our database is stored. So meaning that no other user from a remote connection can change your database as a root user. So we will disallow this as well. And remove the test database, and the access to it will do so as well. Then of course, after we've done all this, we want to reload our privilege tables, because in our privilege tables, actually the connection between our users and our passwords and our access rights is it's all in there. So just say yes, and then it should say all done. And if this worked, you can test again with your MySQL -u root -p. Press enter and just use your new password to log in to the MySQL. Alright? So far we've installed the MySQL server on our system, we've secured our server installation, and we've changed our root password. So we've done all this. If you want to go any further, you can always do some extra security measurement. So meaning that you cannot connect to your database from any other system other than your local host. It's done by creating a my.cnf file, or if it already exists, just adding these two lines to the file. You don't have to do it. In our case, it's okay, but keep in mind that you can do it. And then a special feature for our database users is, of course, if you want to connect to your database, keep in mind that your database users and your operating system users do not have anything in common, actually. But if you don't specify a username, as I've shown you where I just entered the MySQL command without specifying a username, it just takes my username from my operating system. And of course, our database will have a super admin or an administrator, which has all the rights, including dropping your database. And by definition, this is the root at your local host. It's not a good idea to always connect as root, because if you have all the rights, you can mess up all the things in your database as well. So, what are we going to do? Well, if you create a new user, which you can do as root, it will, by default, have little to none or very limited privileges. You can grant privileges on a certain table or a certain database to your user by using the grant statement, where you, of course, have to change your privileges like you want to set them. And here specify the name of your database and specify the name of your table to, and then your username at, and then your host. So in our case, if we would go back to our database, we could do create user and then choose your own username. Let's see. So here you would say your username can be your own name. Then of course you want to specify your host. In our case this will be localhost. And then we want to set a password for this user as well. So you can use identified by, and then here your password. Yeah, without the, let's change it. Create user. And then new user, of course. At localhost. Oh, let's go. And then your password. And then close your statement with a semicolon. This command will create a user by the name new user on our local host, and it will have access to our database using the password in this case, but MySQL will not allow you to choose password as password. So choose something for yourself, which you can remember, and preferentially not the same password as your root. Although in our case it doesn't matter that much because we're just working as a single user on our own system. And if you've done so, it will say query OK, 0 rows affected, and you've created your new user, but this new user does not have any rights, and as I mentioned, you can use the grant command. So just to grant, and we want to give our user all rights, so we will just do grant all on, and then specify a database and a table name. But of course by now we've not created any databases or any tables, but the grant command works on all future tables and future databases as well. If we use these wildcards, so we have already specified all privileges, and we want all future data, present and future databases with our wildcard, so just a star, and all tables as well, so star.star, and then 2, and then of course your username, so in our case this will be new user, and again at local host. Semicolon, and just press enter, and you will see that your new user will have all rights on all databases, present and future. Alright? Any questions so far? No? So now every time we want to connect to our MySQL monitor, we will have to retype the MySQL -u, your username, and our -p and our password. This is quite safe, but for your local user, you can also store these credentials in a config file. So if in your home directory you would create a hidden file .my.cnf and set the permissions to 600, which you've seen in your Linux course, and this file is only accessible for your own use. And what do you have to enter in this config file? Well, basically these are just key value pairs with your credentials in them. And MySQL will use this as invisible command line parameters. So you can put your password in your file. Instead of using MySQL -p or password, this password, you can just create an options file with these 3 lines where between square brackets you type client, password, and then of course your own password, username, and then your own username. And then MySQL will use this file as credentials, and you will only have to type the MySQL password, and it will connect as this user. Of course, you can only add one user here, otherwise MySQL will not know which user to choose. Alright? And then if we want to interact with our MySQL monitor, we will need some sort of language, and we will use the SQL or structured query language, which consists of 4 main parts. Our data definition language, with the create, alter, drop, and so on statements. And these are actually to design our database. So create a table, create a database, alter a table, alter a column, or drop our database, meaning delete our database. And then our data manipulation language, which is actually the most important part, is to manage our data. And as mentioned before, our CRUD operations come back into play, so we can create new data, read data in our database, update data that's already available, and remove data from our database with the delete command. In order to change the database rights, we have the data control language, which we already touched with our grant command. And then as an extra, you also have transaction control language. It's to manage all of the data manipulation language statements, where we can group certain statements together or undo a certain statement. How does a SQL statement typically look like? Well, you have certain clauses, for example, update, and then the name of a table, or a set clause, or we will set the name of a column with an expression. An expression can be a mathematical expression, or can just be a string, or a full array. So in this case, update movies, set rating is equals rating plus 1, where name equals USA. We'll just update all the ratings, or increase all the ratings from the movies in our database with 1, but only from the movies that have the name USA. Alright? Going back to our MySQL monitor then, if we connect it to our database, we can always enter SQL statements in there, but there are also other ways to execute these SQL statements in our monitor. So if you just connect to it, enter your statement, but you can also do it directly from the command line. If you would use the MySQL -e and then between single quotes your SQL statement, it will execute the statement command line, give you the command line response. Keep in mind that database here posted between square brackets is just optional. So if you do MySQL space and then your database name, it will do it on this database or connect directly to this database. If you leave out the database, it will connect to your default database. And then a final option is directly from a file. So let's say you have 10,000 SQL statements that you want to execute all at once. Of course, copying and pasting them one by one in your MySQL monitor is quite a lot of work. So we can just save them in a file, a statement file, and then we can pipe the input of this statement file to our MySQL command. So either in this way, MySQL and then a pipe from our statement file, or we can just print the statement file to the standard out of our terminal, so with a cut, meaning that just show the contents of this file, and pipe this through our MySQL database. Alright?
Still need to see interactively in from command line.
Yes, so interactively meaning that you first connect to your MySQL monitor and then just type in a statement from the command line saying do not connect to the MySQL monitor, just pipe or send the command through and give me the response of the command. Alright, and as mentioned before, only users with significant privileges can create new databases. In our case, our root user, and if you followed the instructions I gave you, also your own user, because we've given them all privileges on all present and future databases. And we can create new databases directly from the command line with the MySQL admin command that is provided when installing a MySQL server. And you just do MySQL admin, create, and then the name of your new database. Of course, keep in mind that if you did not set your config file, you will have to use the same arguments as you will use with the MySQL command, so the -u and the -p for the user and the password. But a more direct way to create a new database is from within the MySQL monitor. So first connect to your MySQL monitor with the known command, and then enter the statement, create database, and your database name. So, if we would do this, it will look something like this. So we're still connected to our MySQL monitor using this command as root, but we can also do it as our own user. But for now, let's do it as root. We've granted all privileges to the database user you created before. Well, if you created your new user and you executed the grant command, you've done so as well. And then on Leho, there's a file called one.sql. It looks like this if you would open it. Just let me see. It just looks like this. So this is a typical .sql file where you have a bunch of information on how it's created. And here you have your typical SQL statements. So this will drop the table if it already exists and create the same table again with all these columns, with these constraints. We'll come back to that later. And we will do a lock on the table to insert some values and do it a couple of times. So we have a couple of values in our database. Alright? And if we want to execute all these statements in a file, well, if we just do create database, and as mentioned in the slides, I'll choose the name DB, like so. Again, it says currently OK, we have one row affected, so meaning we've created a new database. You can always check by doing the show databases command. And then you will see that our BioDB is right in there amongst the other databases available to use. And then of course, to insert our data or to execute all our statements in the one.sql file, we could just copy it and paste it here in our MySQL monitor, but it will give us a long or a very long statement. So we can always do an exit, going back to our normal terminal. and then just entering the MySQL. Of course, I will have to do it as my root user, because I did not create a new user as you have done. So -p, and then we will type the contents of the one.sql file. Keep in mind that you have to be in the same directory as where you downloaded your one.sql file, otherwise you will have to use an absolute path instead of a relative path. And normally this should work. It should ask you again for your password if you did not set it with your config file. And I did not select the database, so of course I want to do this in BioDB. Again, like so. And if it doesn't produce an error message, then it should be executed correctly. So now we can connect to our MySQL monitor again. We already know that the database is in there, so if you do show database, we will see it. But we can use it by entering the use, if you would like capital letters, and just type a database name, so use BioDB, like so. And it will tell you that your database has changed. So from our default database where we connect to, it has changed to our BioDB database. And now we can see the contents of this database by using the show tables command. And this will show us all tables inside our database. For BioDB, for now, we only have one table in our database called model organisms, model. If we want to see the structure of this table, we can just do show columns to show us all columns from, and our table is named model. And this will show us an overview of all columns inside this table. So, our database BioDB has just one table, model, which has several columns for each row, including the ID, class, the genus, species, the number of chromosomes, the genome size, and a draft date. Here you can already see the type of data that is in there. We'll come back on that later. And some other constraints. Okay, so this will tell you that there are 7 columns inside your data. So this is all stated right here. We've connected as a root user or as a normal user, shown our databases, and checked BioDB databases for our tables and columns. So now we know that our MySQL database is just a collection of tables. In our case, or in our example here, we just have one table, and a table is a set of columns with specific types. And these types can be numbers, text, dates, and so on. Now, one of the features of MySQL is that each row has to be in the same format, and there has to be only one value per field. So if you take a look at this example table, we have certain rows and certain columns, and for each row, the value inside one column has the same format. This is done by specifying a column type, and there are several column types as mentioned before, and the most important ones are stated here. So we have our int, or our integer, meaning a whole number, ranging from minus a very big number to the same number on the positive side. If you use the signed integer, you can also choose to do it unsigned. Then you can only enter a positive number. And there are some specific integer types as well, tiny int, big int, small int, depending on the amount of storage space you have on your computer. Another type of numbers are the floats and doubles, which are just numbers with a decimal point. A float and double differ in the way, in the number of digits they store after the decimal point. And then of course we have our date type, which by default is just written as the year, the month, and then the date. And more specific, you have the date type time, where you just add the time after your date. In particular, you can ask for a timestamp, which gives you a number of seconds starting from the Unix timeline, which means that there are no dates before 1970, and for some reason there are no dates after 2028. But that's just a minor detail. And then one of the most used column types are varchar and char, which basically do the same. They contain strings with a certain number of characters, and you have to define the maximum number of characters you want to use. For example, if you say to your database, I want in this column a varchar of length 200, then no more than 200 characters can be in this field. The main difference between a char and a varchar is that the varchar is way more sufficient or efficient in storage space, but of course your char is faster for reading data. Well, why is this? But if you look at this example, if we want to store the word text in our database, and we will use a char of 10 for this, it will mean that our database will preserve 10 spaces in the database or on our system to store this word of text. If your word is 4 letters long or 10 letters long, it will use the same amount of space. A varchar of 10 will just use a lot less space, because it will only store the length of the text and then the text itself. Meaning that if you have a varchar of 10 but your text is only 4, you will only use half the space of your char of 10. So why is char faster than for reading data? Well, of course, if your system knows by default that every 10 spaces a new word starts, if you just search for a word, it just has to jump every time 10 spaces ahead. If it's a varchar, it doesn't know the length of every word, so it doesn't know if it has to jump 5 spaces, or 10 spaces, or 2 spaces ahead in its internal memory to search for the start of a new word. So it will have to do the spaces one by one, meaning it's a lot slower. And the same goes for integers versus big ints versus small ints, and so on. Another type of storing text is, of course, using text and blob. And this is mainly used for large parts of text that do not have to be queried that often or do not have to be searchable within the end user program. A blob is used for binary data such as images. And then if you know beforehand that you have a limited set of values you want to allow in your column, you can use an enumeration. And this is, of course, very efficient because of the small amount of storage and because of the limited amount of options. So if you go back to our table, then we can see that our column types here could quite easily be an integer for a first number, or first column, a varchar or a char for our name and our last name. Our birthday will be a date, and our sex will be an enumeration, because we know from beforehand we have a limited set of options for our sex. Another characteristic of MySQL is that every row has to be unique. in order for the database management system to be able to distinguish separate rows. And to do so, we use a primary key in our table. And this primary key is actually a column that makes sure that every row is unique. And it's usually the first column, and quite often an integer is chosen to do so because numbers are way more unique than text. And there's an option in MySQL to add an auto increment to your column, meaning that if you have stored a number in your database on the first row and you enter a second row of data in your database, the ID will be automatically incremented with 1. So meaning that if your first row has ID 1, your second row will be by default 2. And on top of these column types, you'll have other constraints as well. So our primary key, we already mentioned that. You can also set a unique constraint on every column or on a combination of columns, meaning that all the values or the combination of these values have to be unique. You can say that your column cannot be null, meaning that you do have to enter data in your database when adding new data, so it cannot be empty. You can set a default value for a certain field, and you can specify a certain field as a foreign key. We'll come back on that later. Foreign keys are quite important when using joins. So basically our MySQL database looks like this. We have a table which consists out of rows, and each row has certain columns, and each column has a certain column type, and optionally some other constraints. Alright? Okay, going back to our database. So now we've just created a database, we've added the data from a file, and we've added some data in our database as well. If we would like to add new rows to our database, you can use the insert statement. And it's just as easy as saying insert into and then your table name, and then one or more column names, the keyword values, and then one or more values depending on how many columns you selected. Keep in mind that the order of your columns and values has to be the same in order to let MySQL know which value goes along with which column. Be aware that not all columns need to be included in your query. So unmentioned columns are given the default value for that column. If you specify the default value with your constraint, it will use that value. If you did not do so, it will give you the null value for an empty column. Of course, columns with the not null constraint cannot be null, so they require a value, so you have to include them in your statement. And strings in these statements are written between quotes. So as you can see here in our example, if you want to insert a new student in our students table, we will say, okay, insert into students. Then we will specify which columns we want to insert data into. So we want to add a student number, a name, and a last name in the new row. And the values for these columns, so for student number, is just this number without quotes. But name and last name are strings, varchar or char more specifically. So we have to add them with quotes. And if you execute this statement, if you have a student table, then we'll add a new row with this student number for this student. Alright? And then retrieving data from our database. So how can we see actually what is in our table? It's just by doing a select statement. And the select statements look like this. So select, then one or more columns from, and your database table. You can use a star again or a wildcard if you want to select all columns, or you can just specify one or more columns separated with a comma. You can also use arithmetic operators and other functions on columns, what will come back on that later. The table in this query can be a single table, so we'll start with that. Or it can be multiple tables joined together. It can be a subquery or a view, but we'll come back on that later. Alright? And if we then want to sort all our rows in our database, we will just expand our select statement. So we already knew select columns from our table, just gives us in random order all the columns that you entered in your statement for all the rows in your database. If you want to sort them, we will add the order by clause, and then you can say order or the results by, and then the name of your column, and in the ascending or descending manner. Ascending is selected by default, so you don't have to mention it. But if you want to be specific, you can add it. If you want descending, you will have to use the descending keyword. Alright? So if you would like to do this on a database, so going back to our mod.org table, if we would like to select the names of all model organisms in the order of publishing date and draft, we will start with a select. And if we select everything from mod.org, it will look like this. In our example, we can do so because we have a very small database, but keep in mind, if you do this on large databases, it will blur out all the results in your database and your system will be stuck. So best to limit your results if you would like to do so, or to be more specific in your query. But for now, we can do this, and it will show us an overview of all rows in our, or all data in our table. So I select all columns, so everything from our table. But we're looking for only the names, so genus and species, of all model organisms in the order of the publishing date. So we can update our query by just doing select, and we only want our genus and species. And then our results look like this. So now we only have two columns we want to use. But they're still not ordered, of course. So we want to order them by the publishing date. So we'll again have to elaborate our query with an order by. And we know from our select star that the publishing date of the draft is in the column draft, and ascending is by default, so that's okay. Now it will look like this. If you want to check if this makes any difference, you can always add your draft column to your, let me just show it like this, or to your draft column, and then you will see that it has ordered our genus and species by the draft column in ascending order. So null will be the first value, and then in ascending order from published earlier to published later. Alright? You can also order by multiple columns. So for the second part, we want to show again the genus and the species of all model organisms, sorted by the number of chromosomes, with the most chromosomes on top, and then alphabetically by name. So our query can be exactly the same, but we will, just to check, include the number of chromosomes as well. And then order them by number of chromosomes, so by number of chromosomes, this is in this column. You can always check the names of your columns with the select star or show columns from, as we've seen before. And we want the most on top, so descending. And then we want to sort them by name, so by genus and by species. Always keep in mind that you have to end your statement with a semicolon, Otherwise, MySQL monitor will not allow it. It will just open the second row. And then we can see that our results are ordered by chromosome from high to low, and then by name. All right? And as mentioned before, you can only select columns that are in there, but you can also add columns in a query that are a calculated value of other columns. And there are a lot of functions and operators readily available inside MySQL. You can just do mathematical operations, or you can use several functions. And these are just some examples. So in the first case, you will just calculate 6 times 7. In the second case, you will create one column that consists out of the class and the genus separated by a space. And in the last part, you will just ask for the date or the date time at this moment. So there are several operators, so as I mentioned before, the mathematical operators, and then some functions. You should not know them all by heart, but know that they exist and that you can. On strings, there are several functions to calculate the length of a word, to concatenate several words, to transform them to upper or lowercase, to get a substring of a word, to reverse it, and so on and so on. On dates as well, you can ask for the current date or just now, and you can ask for a part of a date by using the year, month, or week functions. The D stands for the date that you will have to enter in this case. So if you ask for the year of a date in your database, it will just give you the part where year is in, of course. The same you can do with day of the month and day of the week. An hour, minute, and second is similar to year, month, and week, or day, but just for date types. So going back to our example, we've already executed this query actually, but now we want to use our functions to concatenate them. So we will select, and then our concat function, genus and species, and this will create one new column from those two columns, separated by a space. Then we want the genome size rounded to 4 digits, so we can use the mathematical function round. We want the genome size, and this genome size to place it in gigabases has to be divided by 1,000, as you can see from your database. And we want 4 digits, or rounded to 4 digits. And then we want the average chromosome size, so this is just saying the same as the genome size divided by the number of chromosomes. And then we want the publication year, and we know that our publication date is in draft, so we just ask for the year of draft. And this, of course, is in our mod.org table, and we want to order them by average chromosome size. So again, it has to be the largest on top, so D7. And then you can see that it calculated our results. It created one column with our genus and our species, and it did some calculations on the other columns. Keep in mind that the column names are now, of course, exactly the same as the ones you used in your statement. In order to avoid this, you can also use column aliases. So if in your select query, so as we did here, select concat genus species, it of course gives you this. If you want to give this a more short name, you can always use a column alias. How do you do this? Well, just by adding the alias directly after your selected column, optionally with the as keyword. So this can be full name, for example. And if we do so, you can directly see that in our results, this no longer is concat genus space species, but now has our column alias, full name, and these column aliases can be used in our order by as well. So if we would like to choose a column alias for our average chromosome size, we can do so as well by adding it over here, so directly after our column name as average size, for example. And we can use this in the order by clause, so we don't have to do this calculation again. You can just use average size over here. And this will give us the same results, but with our column aliases. Alright? Of course, so far we've only selected all our rows from our database and just ordered them in a certain fashion. But as I mentioned before, if you have a large database, this will not work. This will corrupt your system or freeze your system. So we have to filter our output rows. Again, we can elaborate on our select statement with the where clause. So we've now known so far our select and a certain amount of columns from our table. And then we add the where with certain conditions and optionally our order by clause. These conditions can be one or more conditions. So if you just do one condition, for example, say value equals and then a certain value, or it can be a combination of values, and that is done with the and or, not an exclusive or, which we'll come back to. Then both of these conditions have to be met, and then only, of course, the rows for which these conditions evaluate true, those are selected and shown in your result. And keep in mind that you're unable to use column aliases in conditions. So the column aliases can be used in our order by, but not in our conditions. How do we filter rows? Well, we can use several numerical comparison operators. So equals to, not equals to, can be written in both ways, like so. So smaller than or greater than, or smaller than equals to, or greater than equals to. And between, if you want to select some values between two values. Keep in mind that x and y value are included as well, so this is an inclusive statement. And for example, if we want to select all organisms with more than 10 chromosomes in our database, we just do our select statement, so select and then our columns we want to see in our result set from our table name, and then add the where clause, where, and the number of chromosomes have to be larger than 10. Alright? And we can do the same with strings, so not only on, we can not only filter on numbers, but we can also filter on characters. We have some of the same operators, so equals, not equals, larger than, smaller than, work in practically the same way. And then, of course, we can also compare patterns with the like keyword. So this matches a pattern, and then we'll have to use some wildcards. So a underscore matches a single character, and a percentage sign matches 0 or more characters on that position in your string. You can always use an R line with regular expressions, but these are quite system heavy. So for example, if we want to select all mammals, we can just do our select query again, but now changing our condition where our class has to equal and then the string mammals. Keep in mind that if you're using strings, you have to use quotes. Single quotes, double quotes, doesn't matter that much, but do use quotes. And then as mentioned before, if you enter data in your database and you did not select the default value and you did not give your new data a value, then it gets the null value, and you can test for null values in your database if you do your select query and then in your where statement just ask if this specific column is null or is not null. In the same way, you can change your result set to show another value if the column should be null with the if null clause in your select statement. So in our example, we want to select our genus or species, and then with our if null statement, if the null value, so actually the null word, is in our database, for the number of chromosomes, we want to replace the word null with the value 0. Alright, and as mentioned before, if we want to combine several conditions, we can do so by using Boolean logic. So not x will mean that it only evaluates true if the x, so the condition, is false. X and y will only evaluate true if both conditions are true. X or y will evaluate true if x is true or y is true or both are true. And the exclusive OR will only evaluate true, so give you the result or include the row if x is true or y is true, but not if they're both true. Alright? And then, going back to some examples, so I will only do some of these. For example, if you want to select all mammals with genomes published after 2005, well, just select all columns, doesn't matter, from our mod.org. And then, with our where clause, we will enforce the condition on our results. So, we only want mammals, so we know that our class has to equal mammals. And they have to be published, or the genomes have to be published after 2005. So it has to have 2 conditions, and our year from our draft has to be after 2005. So larger than 2005. And in this case, there are none. We can check this. If it's correct. No. We try again. Mammals first, yes, and then year from draft. No. So I have So if you just select all mammals, we can see that it selected 4 rows, just the mammals. And then if we add the condition that the publication of the genome has to be after 2005, we'll see that this row is excluded. So we only keep rows where the class is mammal and the draft year is larger than 2000. So it has to have both conditions. And in the same way, we should be able to look for these. Just search for the right conditions and it will give you a result set. Because our database is very small, you can always check them manually if you would like to do so. And then if we filtered our rows, we can also limit our output. So let's say we filter on our database, but our results still contain 1,000,000 rows, for example, but we only want to see the first 100 rows, then we can limit the result set by using the limit keyword and then a number of rows. Optionally, you can add an offset and a number as well. And if an offset length is given, then the first and then number of rows you specify with your offset, that amount of rows is skipped. A limit is mostly used in combination with an order by. For example, if you're asked for the second largest number of something, or the second group with 10 names in them, or something like that. If you want to do this on your own database, for example, let's choose the second one, show the organism names of the top 3 largest genomes. So the organism names are in genus and species, of course, as we can remember. Again, from our mod.org table. And we want the 3 largest by genome size, so we have to order them by our genome sizes in this column, and largest on top is descending. So if you do so, we will have this. If you want to check if this is correctly sorted, you can always add your genome size in your result columns. And you will see that it's correct, but we're only interested in the 3 largest. So we will limit our result set to 3 results. And then you can see that we only get a result set with 3 results, 3 largest on top. Alright, so far we've selected data from our database, we've limited our results to a certain amount of columns, we've ordered them, we've put some conditions on them, and then we limited the number of output results. But of course, sometimes you want to do a calculation for a single result across multiple rows. And in order to do so, you will need to use aggregation functions. And SQL allows you to specify criteria to group rows together, calculate a single value per group of rows, and filter that group data. And again, it has some built-in functions to do so. A count function is quite often used, but you also have a sum, a minimum value, maximum value, average, and some other statistical functions. So, if we would look at this in practice, it will look something like this. So select count star from mod.org. This will just give us the total number of result rows in our database. If we would do select count and then a specific column, it will give us the number of results in our result set, excluding the rows for which this column has the null. So meaning that if we would do the first 2 in our database, so select count star from mod.org. Then it will look like this. We have 10 results in our database. You can always check it if you do just select star from mod.org and count them manually, but as you can see here, these are incremental, so it's just 10. But if we would like to do a count from or on our number of chromosome column, you will see that the result is 9. Well, this is because if we check here in our number of chromosome column, we have one row with a null value, and this is not included in our count. Alright, so if you've done an aggregation function on your database, you can always group those results, so sort data into groups in order to do your aggregation function on them. And then all rows with the same value for that certain column are grouped, and for each group your selected aggregation function is calculated. In your query, it does not make sense to select other columns than the column used in your aggregation function or in your group by function more specifically, because MySQL will just throw out an error. So for example, if we want to calculate how many organisms are present in the dataset for each class, then of course we will have to group by class, because as we can see in our database, there are several organisms for each class. So our select query will look like this. We will select our class, and we want to know how many organisms there are per class, so we will do a count for all rows in our groups. And because we want to know a number of results per class, we will group by class. So what we've done now is selected some columns, firstly grouped our results by class, and then counted the number of results in each group. And this will result in the following output. And now you can see that for each class, you can see the number of rows in your database. You can always check this if you just do a select star on your mod.org table and count them manually. But of course, for large databases, this does not work. Okay? And then again, if you've done some aggregation functions, you can always filter them as well. But of course not with the where clause, because that does not work on aggregation functions, but with the having clause. So a having clause is always combined with a group by. And it just again is added to our select statement. So we have select, then a column or an aggregation function on a column from our database, optionally with a where condition already, and then they're grouped by a certain column. And now we want to filter these aggregation results with our having statement. And in our having statement, we can again just add a condition. These conditions can be similar to the conditions used in a where statement. Keep in mind that you can use your column aliases in your having clause, whereas in your where clause that was not possible. And if you've done so, you will see that your select statement, in theory, can look like this. So this is the order of your select statement. Select and then a certain amount of columns. This you can skip. Here you can add your columns as well. From your table name, you can add a where condition. You can group your columns. You can sort them, and then then you can filter your aggregation columns, you can sort your normal results, limit them, and then you can always output them into a file or in a dump file, but these last parts are optional, at least for now. So what is the execution order of your select statement? Well, firstly, of course, your input columns are determined, and then they are filtered with the where clause. After this first filtering, they're grouped based on your group by, your columns in your group by clause, and then your aggregation function is calculated on your groups. After this aggregation function, your results are again filtered with our having, and then they are ordered by your column. And in the last step, your output is chopped with your limit and your offset. So, this means that for this example, our query will look something like this. We will select our class and an average number of chromosomes. We will use a column alias, average chromosome, from our multi-arc table. We will group by our class, because we want, for each class with more than one organism, we want the average number of chromosomes. We of course want only classes with more than one organism, so having a count should be larger than 1, and then sort the results such that the biggest average is on top, so we can add an order by, and then average chromosome, and the largest on top, meaning D7. Of course, you have to select the correct table name. And this will look something like this. So what do we do in our query? We just selected our class and then an average number of chromosomes. So firstly we grouped all our rows by class. Then we filtered these groups with more than one result. Then we calculated the average and sorted them by average. Okay, so this is basically an elaborate standard select state. All right. And then, of course, we can grow our database. So far, we've only used one table in our database, but a database can consist out of multiple tables. And for this example, we've created or I created a new database with more than one table. So I will create a database. Okay, and then I can just insert this database in the newly created database, so the contents of this file, like so. It's the same as we did with our first database, and if this works, we can just connect to our monitor again. Do our show databases command, and then you can see that our new database bioinf is in there. And now we can see that in our new database of bioinf, there's not just one, but 3 tables with our model organisms, our gene table, and our class table. And this brings us to the next part of our select statements. And these are the joins. So relational databases, of course, have different tables, or in most of the time. And joins allow you to combine information across different tables. So going back to our students table, previously we just had our student number, name, last name, and a birthday. But what if we want to expand this with trajectory and course info? Well, there are 2 problems. We have redundant information, as you can see here. So this information and this information is stored in our database on several rows, which is of course a waste of space and quite error prone, meaning that if you enter a new result, you have to make sure that the way you write a certain value is exactly the same as it already is in the database. And the solution to do so is to create a relational database with a foreign key, meaning that in your original table, you substitute your value for an ID, and you create a new table which links this ID to the actual value. Keep in mind that the data types of your linked columns have to be equal, so your foreign key, meaning this one will be foreign key, has to have the same column constraints as the column it refers to in your other. And we can do the same with our trajectories and courses. And then our database will look like this. So we will have not just 1, but 3 tables, or actually in our case 4. Because if you split up your database, there are several types of relations. And the most important ones are the one-to-many relationship, meaning that one result from one table is linked to multiple rows from another table. In our case, this is like so with our trajectories. So one student can follow one trajectory, but the trajectory can be followed by multiple students. But between our students and our courses, there is a many-to-many relationship, because a student can follow many courses, but a course can be followed by many students. And these many-to-many relationships are actually a combination of 2 one-to-many relationships, but with a cross-reference table. So if you would like to split up your courses from your students table, you will need to create a cross-reference table in order to do so. This cross-reference table most of the time does not contain any real information. It only contains an ID and the foreign keys of your other tables. Alright? And if we would then like to join our tables, we can do so with a query. So keep in mind that your data representation does not have to be equal to the way the data is stored. So if you look at this table, it's not because you have 4 columns that if you do a query on your database, you have to show the result or the data from all 4 of these columns. I'm using a join. How do we do this kind of join? Well, we just use our select statement again, so we can select all columns from our students table, and we want to join our trajectories table, and then of course we have to specify on which columns we would like to join. So for our students table, we would like to use a trajectory ID, and this has to be equal to our ID in our trajectories table. So just saying that we want to select all of this information is as easy as saying I want all this information and join it with this information. But of course, these rows have to be linked to the correct rows in the other table, and this is done on this value. So trajectory ID in our students table has to be equal to the ID in our trajectories table. Alright? And if we go back to our database, you can see that we now have three columns: our model organisms, our classes, and our genes. And our class ID inside our mod.org table is a foreign key that references our ID in our class table, and the same goes for the mod.org ID in our gene table. This is a foreign key that references the ID in our mod.org table. So a standard join is actually a Cartesian product, so meaning that it just multiplies all rows from every table. So let's say in our database, table class has 6 rows, table mod.org has 10 rows. If you do the query select star from mod.org and class, so basically saying the same as select all columns from mod.org and join them with class, then your result set will have 60 rows, because you did not specify on which columns you would like to join. So a join has to be a filtered Cartesian product, and there are two types of saying this. So you can just do a select star from, and then your columns or your tables you want to join, and then specify it in a where, but more clear and more often used is to do it with a join, because then you know for sure that you're joining several tables, is to do a select statement where you select one or more columns from one table, then do a join with your second table, and then specify with the on clause which columns you want to join. Be sure if you do so that you avoid ambiguity, so meaning that if you select data from 2 tables, and in both of these tables there's a column with the same name, MySQL will not know which one to select, so we'll have to be clear to specify from which table you want to select which column. So if you look at your select statement, and if you don't specify it, for example here our ID column is present in several tables, so you have to specify it with your table name, then a dot, and then your column name, in order to tell MySQL from which table it has to select the ID column. Okay? You can also use joins to join a table with itself, or select data from a subquery. And then you can use aliases in order to make your query more compact. So for example, if we want for each class the class name, the organism name, and the date the organism that was sequenced first, well, we start off with our class for each organism. So our select statement will select the class ID and the minimum draft date from our mod.org table, and we will group them by class ID, because we just want the first organism that was sequenced for each class. And if we would like to add the class name, we will have to join these results with the class table again. And if we want to add the organism name, we will have to join it with the mod.org table. And our query will look something like this. So our first query, select class ID minimum draft, will still be in there, but we will select the name and the draft from this result set, and then join it with our class table here, and specify that our class ID has to be the same as the class ID within our intermediate results. And if you would like to add your organism name, then you will again have to expand your select query with join on your mod.org table, and then of course your conditions will be expanded as well with an and then where you say that the draft has to be the same as the draft in your intermediate result. Of course, to do so, there are different types of joins. There's an inner join, left join, a right join, and an outer join. At least in theory, an outer join does not exist in MySQL. It does in other database systems. And an inner join, it's best to show this with an example. So it will join everything that is present in both tables. So if we look at our students table and our trajectories table, and we want to select everything with an inner join, it will not select the last row because this is not linked to a trajectory, so it has trajectory ID null, and it will not show the last row from our trajectories ID because there's no ID 3 in our trajectories ID. Quite straightforward. If we do a left join, as the name says it, we will select everything from our left table and join it with the results from our right table. So meaning that we will select everything from the table we select first, because we read from left to right, and then join it with our trajectories. Of course, the last row here will not be present in our result set because this has no trajectory ID inside our first selected table. The right join is just the other way around, so it will select everything from your second table and join it with your leftmost table. And then the outer join in theory will look something like this, where you select everything from both tables. Some characteristics of our joins are basically the same as with our normal select statements. So a star is used to select all columns from all tables, so it's again a wildcard. And if you want to specify a column, you can use the notation table name dot column name in order to make it clear to MySQL from which table, which column you want to select. Keep in mind that joins are very inefficient, so they use a lot of memory and take a lot of time. So if you can limit the amount of joins in your query, that's only beneficial for the speed of your query. And it's always a good idea to use the on clause to specify the linked columns. So meaning that if you use the join keyword in combination with your on clause, it's way more clear for yourself than at least than using the join method with just a cause and a where. And of course, if we want to place these joins inside our select statements, what is the execution order? Well, we know from our normal select statement that the input columns are determined, and then it uses the join clause because we can select columns from both tables then, or from multiple tables. Then it filters the input columns, groups them, calculates the aggregation functions, filters the aggregation functions, sorts the output, and chops the output. In theory, or in practice, this will look something like this. So if we want to select for all rows in the table gene, the organism name, the class name, the accession number, the length, and the description of the gene, our select query will look something like this. We will select name, genus, species, the accession number, the length, the description. And we want this for our gene table. But of course, not all this information is in the gene table. So we would like to join our mod.org table where, and we know this from a few slides back, where our mod.org ID and our gene table will have to be the same as our ID in our mod.org table. So meaning that we'll join on. Then inside our gene table, so gene.mo ID will have to be the same as mod.org.id. And then we can join again with a different table, join class on, and then in our mod.org table we have a class ID column, and this has to be the same as the ID column in the class table. So our statement is saying select this bunch of columns from starting a gene table, then join your gene table with your mod.org table based on a certain criteria, and then join these results with the class table based on a certain condition as well. And if you do so, yes, of course, I have to select my bioinf first because I reconnected. And then it will look something like this. Then you can see that we have all these results, and this data is actually coming from our three tables. Okay. As I mentioned before, when using a lot of joins, your queries tend to become very complex, and complex queries tend to become slow. So they produce a large system load and or produce a slow interface, and your user has to wait for its result, and that's something we want to avoid. So mind your choices of column types, of course, and included columns in your query. So, for example, if you're looking for just a name of a student, don't ask your database for the birth date and your student number as well, because everything that is shown in your result set will ask for system resources. But of course we can speed things up in another way as well. So frequently used queries can be sped up by using views, indices, or by allowing a certain amount of returns. Views are actually a kind of table which you create, but it's a read-only data source. And this table is stored inside your MySQL memory. It's a virtual table. And you can just query on this table like you would on a normal table. Meaning that if you normally would execute a query with a certain amount of joins, you can save this in a view, and then you can just query this view without joins, so it goes a lot faster. This comes in handy when you want to reuse the same query over and over again, and of course your speed gain depends on your use case. There's a difference between the way views are stored between different database management systems, but for MySQL it's stored in a virtual table. How can you create a view? Well, it's as simple as saying create view, and then selecting the name for your view as, and then adding your select statement as you would do a normal select statement. And then to use your view as a table, you can just do a select statement, but instead of using your table name, you will use your view name, and everything else stays the same. In our database, this will look something like this. So if we want to create a view from the query from our previous exercise, so this one with all these joins, maybe, yes. Then you can just reuse your select statement, add the create view, and then we will choose a name, so in our case, for example, gene view, as, and then our select statement, and this should be fine. Alright, so it says query OK, 0 rows affected because we did not change anything in our database, but our view is created. If we now want to select data from our view, you can just do select star from gene view. And then you can see that it goes quite fast. Of course, for a small database, it does not make that much of a difference. But it's way easier to do just a select star from gene view instead of doing a select name, gene, species, join with this table, join with that table, in order to get the same results. So if you would, in your program or in your script you would like to write, reuse this query several times, then you can just create a view, and then you can swap your code around for just this small part. So then you can just calculate whatever you want on this view. Of course, when using the show tables command, your gene view will pop up there as well, because it's a virtual table stored in your results. Another way to speed things up is by using an index. And an index is used to quickly find certain rows, like you would in your in an old telephone book, or like you would in your address book on your smartphone. For example, the first letter of a name can be used as an index. If you go to the letter M, for example, it will just quickly search all these letters. Indexes are stored separately, and just abide by one golden rule. You can use indexes on the column you will use in your where clause. This speeds up your query quite sufficiently, but keep in mind that only one index per query is used. You can create an index by using the create index statement, and then give your index a name on your table and select a column. A foreign key is by default an index, which is used to speed up your join queries, but it's not essential for join queries. So you can join on other columns than your foreign keys columns as well, but it will be a lot slower. And then the last way to speed up your queries is to allow redundancy, because the database schema with the least amount of redundancy isn't always the quickest. So you can allow your database to store the same information twice or more. This is often used in data warehouses where you want real-time reporting. So let's say an Amazon website, for example, where you want your search results very quickly. They use a different strategy than other systems. And in order to do so, there are two kinds of database schemas which are quite important. You have the snowflake and the star schema, where the snowflake schema does not allow for any redundancy, and the star does. Of course, your snowflake scheme will be much more easy to maintain and change, because every piece of information is only stored once, whereas in your star schema you will have to make sure that if you update your database, you will have to update it in the same manner on several places. But of course, the main advantage of allowing this redundancy is that you have lower query complexity, which means less joins, and it makes your system quite a lot faster. Of course, it uses more space on your system. So this is basically two times the same query, one with the snowflake one with star, and as you can see directly, our query is way less complex, so this query will be a lot faster than this, and it just gives us the same result. Both systems look similar. They have a fact table, which is just your centralized table, and then they have dimension tables, which include attributes of the facts, and in our star scheme, redundancy is allowed, yes. And then a final part, of course, we've selected data. We've selected data from multiple tables. We've filtered data. We've grouped data. But of course, if we want to back up our data, you can just make a dump file out of your database, or if you would like to do so, into a text file. So just by using the MySQL dump command, this is command line. Keep in mind that this is not executed from within your MySQL monitor. So just in your terminal, do so. MySQL dump, and then of course additional options if you did not use a options file, so your username and your password. Select the database and then just pipe the output to, and then the database name or name of your own choosing, .sql. And this will create a file similar to the ones we use now to populate our databases. These dump files typically contain statements for creating the database, for creating tables and views, and for inserting the data. So if we looked at the contents of the 1.sql file, this is actually just a dump file of the first database we used. And in order to restore your database, you can always just re-enter your data inside your database the same way as we did before when populating the original databases. And if you would like to do so, you can always create your own dump file, check the contents of the files, and then if you're really brave, you just delete all your databases and repopulate them with the contents of your dump file. Alright? Any questions? No? So next time we can elaborate some more on relational databases and touch the subject of normalization as well. Alright? Thank you.